a long section in the chapter, but it's a really good one. A lot of good information here. So this next little figure shows the prime interest rate for England, more or less. And we've got the same thing. You know, our Fed sets an interest rate, and the interest rates are at historic lows. And I am not much of an economist. I've tried to learn more about it recently, but you look at this very low interest rate, and what it means is what it tells me is that a dollar in the future is going to be approximately about what a dollar now is worth. I mean, the reason for the Fed to reduce the interest rate is so that the economy accelerates or keeps going. It's supposed to make, it sounds weird, but it's supposed to make money cheaper. Make money just itself becomes less valuable, and therefore, your bank, your local bank, which needs to make money as well, because they're sort of the middleman between you, the consumer, and the big banks that fund them. They need their interest rate to be a little bit higher. They need to charge you a little bit more than they're getting charged. It's the same thing right back to Northwestern Energy being the middleman. Think of you, the consumer, out here, and somewhere over here is the big bank. The primary lenders. When we look at this figure, you can see, oh gosh, we better do something. We better drop the overall interest rate so the economy doesn't tank, so that people actually continue to use money. All right, that's what. Yeah. The interest rate net of inflation. I'm gonna read from the book because that's a little more obscure. This is right in the middle of page 438. It says, in order to adjust for the effects of inflation, a real interest rate needs to be calculated rather than the purely monetary one. And it says this is simple enough, and it's real interest rate equals the monetary interest rate minus the rate of inflation. Okay, I guess that makes a little more sense. I'll write that one out so we can all see it here. So this is on page 483. So the real interest rate equals monetary interest rate minus rate of inflation. Now, what's the rate of inflation? Well, we looked at that a little bit earlier in the chapter with that little basket of goods. It's just how much more expensive things actually become. So, and I don't know if this is relevant or completely relevant, but any time you've got three competing values, there are all kinds of ways to create unpredictability and instability. And even like some of the top physicists have problems with this. I don't know if you remember some of the quotes from Einstein. He was like, I can understand relativity all day long, but I will never understand compound interest. Like, what do you mean? Going, not to get too philosophical, but I think we discussed previously that money and currency is just sort of an agreed to thing, and a dollar bill is going to mean a very different thing to the guy standing out in front of the Albertsons versus Bill Gates, who wouldn't even slow down to pick the thing up if there was one blowing past his foot. Right, it wouldn't be worth his time. It would slow him down too much because he's busy making several $1 million a minute on whatever his investment. So even a dollar has a relative value depending on where you are, who you are, et cetera, et cetera. So it can get extremely complex. But that's more or less what this figure is showing.
Well, me and my dad were talking about rate of inflation for how everybody complains about gas.
Mm.
Well, back when I was 16 years old
Yeah.
and first got my license, gas was $1 a gallon.
Right.
And milk was $1 a gallon.
Oh, okay.
Milk is now almost $4 a gallon.
Right.
And gas is like, what, $2.39,
Yeah,
$2.50?
yeah, yeah.
Everybody complains about that.
Right.
But they forget to take a look at how much everything else has inflated as
The
well.
relative rates, yeah, yeah, no, that's a good point. I had a similar conversation with my father, about the stock market, you know, so the stock market prices, I mean, it's always positive. And so my question is, well, why, how could a stock value ever go negative? Well, if it did, well, no one would buy it. I mean, you'd have to pay someone to take it off your hands. And so what really matters in the case of stocks, and it's the same in the case of money, because if you add up all the money and there isn't any money, then it adds up to zero. But so the stock market is just based on, again, just relative perceived values of worth of different stocks. So I guess in that sense it is kind of just a funny bubble, you know. It's speculation too. It's a speculation based on what the future value of something, you know, buy low, sell high. Okay. Now I do want to dig back. Here it is. The next. No, I don't want to skip ahead this far yet. What I do want to show you is a spreadsheet that you're going to be using in ETEC 214 in the spring if you take it. I think it's either week 2 or yeah, it's pretty early on in the semester, but there are 3 different ways to think about money. One is the present value, you know, what a dollar is worth now. One is a future value, and then the third way is this sort of annuitized value, what it's worth sort of midway through the cycle. So what I'm going to do is just start off with a very simple discount rate. It's also the interest rate, same thing. I'm just going to put it down super low, just so it's non-zero, and we actually get some answers. And I'm going to say I've got $1,000 right now, and I want to know what it's going to be worth in the future. Well, in this case, since I'm only looking at a term of 1 year, $1,000 now is the same as $1,000 in a year, because, well, just look at them, all 6 numbers are the same. Let me now take this to 2 years, and we can see that and again, it can either be years, you could also think of it as months, doesn't really matter how you do it. And let me look at this annuitized value. Yeah, so in fact, this is in table 12.1, the annuitized value of capital. So if you look, just take a look at that very first corner where you've got $1,000, and let me just, in my little spreadsheet, I'm going to type in 5. Yeah, so if I've got 5 years, $1,000 now at 0 interest rate, each year I'm going to need $200 to cover that. It also means on the flip side that if I'm putting in $1,000 a year, so that's the annuitized value, I'm going to have $5,000 at the end of 5 years. So hopefully you can see that, again, there's the present value, what the money's worth now, there's the future value, what it's worth in the future, and then there's the annuitized value. So with this little spreadsheet, and what we did, I just typed in all of these functions by hand. because it was, well, it was a fun learning experience for me. And if you take a look at your book on page 484, I'm looking at V sub P. I think it might actually be this one. Yeah, they start to get kind of complicated here. Let me just find the right one here. Bear with me. B6 negative B5. Yeah, that's it. Okay, so the equation V sub P equals V sub N. In this case, the N would just be 5. The value in 5 years. So the value presently in 5 years, it's whatever is the amount in B6. So that's the value in 5 years times, and the way it's a little bit confusing here, I use what's called the power function. So I'm just taking 1 plus whatever is in B4, in this case I've got it set for 0%, to the negative B5 power, to the negative 5th power. And let me just set another discount rate. I'm going to use a value from your book. I'm going to use 10% instead. Yeah. So if you scroll over, you can, if you're looking at table 12.2, you can see that a capital repayment period of 5 years, which I have right there in cell B5, at a 10% discount rate, which I have in cell B4, ends up being $264 per year. So that means that if I've got $1,000 and I'm going to invest it over 5 years and I'm going to get 10% per year, basically means I'm going to get $263 a year, is what that means. So, okay. So all these functions are built in, and when you get to 214, you'll have the opportunity to plug these in. There are also functions in Microsoft Excel that do it for you. I don't know if we use.
I'd like to see a CD rate like that today.
Yeah, wouldn't you?
Remember when I was like 12, my dad was trying to teach me about banking, like took out a CD,
Yeah.
it was like 7.5%.
I know, I remember, yeah.
Now you can't get one for any more than like 2.5.
I know, yeah. Yeah, it's just kind of weird that money.
You can't make money with money anymore. You just can't. Unless you really know the stock market,
Yeah.
and that's, most people, they can't grasp it.
Yeah.
Seems to be our government's theory.
Yeah.
Warm up the old preference.
Well, and then of course, all of these calculations come back to affect the curves that we're looking at. So you could take each one of these curves and say, well, at a non-inflation adjusted rate, this is what it looks like. If there was inflation or deflation, the curve's going to be higher or lower. If you have interest on it, obviously these curves are going to be higher or lower as well. So yeah, money has relative value over time. Okay, how are we doing on time? We've got about 8 minutes left. I think we can. Yeah, this is a fairly long and complicated section. I'll just do a little bit more. I think we'll have time. Yeah, we have 5 lectures left. Tuesday we can finish this chapter up. We can talk a little bit about the summaries if you want to. I'd like to talk a little bit more about summary 5. But let's just go ahead and wrap up this section, and then we can figure out what we need to do on Tuesday. So table 12.2 shows the Sizewell C nuclear power station cost breakdown. So obviously there are different categories of costs. So there's the fuel supply, there's the fuel disposal. Kind of strange that the disposal is almost 1/3 the cost of the supply. Operation and maintenance. And now you'll notice that they're giving all of these numbers on a kilowatt hour basis. And that makes sense, because that's what it costs them. That was the left side of that equation that we looked at in the very first line. And as it turns out, it comes down to a really cheap 1.1 pence per kilowatt hour. I mean, that is just dirt cheap. Now, when it has to be taken down or dismantled, this is going to there's decommissioning involved. We did the same thing. We decommissioned the hydrogen fueling station for Missoula College to go into place. So the university paid their facilities guys a little bit to come over and help us, but we actually paid energy technology students a little bit to take the thing down last fall. It was a good lesson in this kind of thing. So you can see here from this chart that you've got a lot of initial costs putting the thing up, and then your operations and maintenance are kind of flat here for a while, and then here's your decommissioning, and then way out in the future at some point you've got to do something else with the fuel. So and if you want to make money in this game, you're well, I guess they don't have the dollars. If they actually had revenue up here somewhere, what you would want is for another line to be higher, obviously, than the red line, so the thing makes money in the end. And you can get investors, right? I mean, you want somebody to come and put money into it so they can get money out of it later. Okay. Again, two separate curves showing that over time, nuclear is going to be more expensive than combined cycle gas turbines. And you'll do a lot of this in NRGY 214, ETEC 214, just comparing. You can do the same thing for wind and solar. When you get to 102, we're going to have you look at a geothermal install versus a wind install and do this exact same deal.
Oh, that's right. Sean was just telling me about that.
Yeah, it's good little.
He said, hold on to all your homework.
Yeah.
You don't want to do.
Yeah. So this is called a spider diagram showing the sensitivity of electricity costs. So so depending on what your cost per kilowatt hour is, the different fuel, capital, discount, operation and maintenance, and load factor are going to have different relative values. So if your cost is relatively low, in general that means your fuel cost is going to be quite low as well. And so you can from this you can see which it's most sensitive to. If you don't have sufficient load on the system, that's going to affect it because you've dumped all this money into building and then people don't use it, so it becomes more expensive. Same thing happens with big municipal water systems, and you got to build a thing, and you kind of hope people use water down the road, so pay it back. Now here's an example of somebody who put together a grain oil-fired power station on the Thames, and hasn't happened. They're just natural gas came online, renewables came online, and people just were not into burning oil for energy, so Yeah.
A couple of millions of dollars just.
Yeah. Okay. I'm just gonna flip through the rest of the figures in the chapter. Here's somebody, 1984, protesting coal prices in the UK. What it says in the UK, between 1980 and 1990, government grants to the loss-making, so the federal government was subsidizing the coal industry in Britain in the 80s. It says the choice between subsidized home-produced coal or cheaper imported coal resulted in a showdown. And you could see the same thing happening like in manufacturing. And to a large extent, that's kind of what a lot of our political debates are about right now. You've got Donald Trump saying, keep the immigrants out so that they don't drive down the costs. And even went so far as to say, what if we had a whole bunch of journalists coming over the borders? Would the journalists then take my side on the whole immigration status? So I mean, the man is not without a point. I'll give, and that's basically what's going on here. Someone's saying, hey, I want to keep my local, domestic, more expensive coal, and you foreign suppliers can keep yours. Global fossil fuel subsidies. So coal did not really have to get a whole heck of a lot. Oil did, gas did. If you want to take a look, there's a neat figure. I might even have it somewhere on my computer, just showing relative subsidies. Look here. I think I might even
Why
have
does coal not need subsidized as much? Because it's more available in most areas.
Yeah, I think it's just fully developed and making money. It's already made back its capital, and it's just kind of running steady state. I think, David. I mean, that's my best guess on it. Oh, here, this one. So you can either have direct investments, and this is a little bit old, but it's showing how many federal dollars have been spent on the various fuel sectors. So you've got renewables on this side. Here are your traditional renewables, wind, solar, what have you. Here are your non-conventional, so purpose-grown grains. And, to get these things started, the Fed puts some, initial money in, and then you get rolling and hope it pays itself back. So there's not only investment, but also tax breaks. So I think the outer ring in each one of these cases are tax breaks. The inner are direct investing. The other thing to consider here is, and again, getting back to that sort of cost per kilowatt hour, a lot of people argue, well, gosh, coal-fired power plant on a acreage basis is making a heck of a lot more energy than a solar plant is. So you're even though this number might be smaller, it's less effective on a per kilowatt hour basis. So something to consider. All right, guys. I think that's about it for chapter 12. I think we're good. Tuesday, Tim's going to come in and give a neat little problem. I'm going to have lunch with National Center for Appropriate Technology, and then we'll move on to the next couple chapters.